Hello everyone, you are welcome to provide a solution given this exponential equation which is x minus 2 to power 6. This is equal to 7 to power 6. So what are the values of x? So if it is your first time you come across videos from this channel, kindly subscribe so that you can get notified when I upload new videos. And thank you for any returning subscribers. We greatly appreciate. So now solution from here, we have that x subtract 2 to power 6. This is equal to 7 to power 6. So the first thing to do here, let's take 7 to power 6 on the left hand side so that we'll have x minus 2 to power 6 subtract 7 to power 6. This is equal to 0. Now the next step here, we can express x minus 2 to power 6 as x minus 2 to power 3. Okay, all this raised to power 2 subtract 7 to power 3 raised to power 2. All this is equal to 0. The next step here, you find that this equation actually, this is in the form of a squared minus b squared, which we can express as a plus b, a minus b. Okay. Now from this equation here, a is equal to x minus 2 raised to power 3 and b is equal to 7 to power 3. The next step here, we have a plus b, this is equal to x minus 2 raised to power 3, okay, plus 7 to power 3, this is equal to 0. Let's call this one equation 1. And we have a minus b, this is actually x subtract 2 to power 3, subtract 7 to power 3, this is equal to 0. So let's call this equation 2. So let's start with equation 1. I will call this one case 1. Let me start with case 1. Case 1 here, this is x minus 2 raised to power 3, that is plus 7 to power 3. This is equal to 0. Now we find that this is actually the sum of two cubes expressed as a cubed plus b cubed, which you can express as a plus b, okay? Then a squared minus ab plus b squared, okay? So applying this identity, then this means that we'll have x subtract 2 plus 7. And then here we'll have x subtract 2 squared, okay? Subtract 7 multiplied by x minus 2, then plus 7 squared, okay? All this is equal to 0. The next step here, we have that x minus 2 plus 7, this is the same thing as x plus 5. And then here we have x minus 2 to power 2. This is in the form of a minus b squared, which you can express as a squared plus b squared minus 2ab. So applying this algebraic identity, the first part here is x plus 5. This is equal to 0. Okay, and the second part here, we have x squared, okay, subtract 4x plus 2 squared, which is actually 4, then subtract 7, okay, multiplying by x, we have x minus 2 plus 7 squared, which is actually equal to 49. So this is equal to 0. Okay, so let's proceed from here. Now here we have the first part is x plus 5 is equal to 0. Let me call this one x1 is equal to negative 5. The second part here, we have x squared. This is actually x squared. Subtract 4x plus 4. Okay, let's open this bracket here. So this is negative 7 times x, which is negative 7x. Then negative 7 times negative 2. This is actually plus 14. Then plus 49. This is equal to 0. Now, we have x squared. Let's correct the like terms together. We have negative 4x minus 7x. This is negative 11x. Then plus, we have 4 plus 14, which is equal to 18. Then plus 49. This is equal to 0. The next step here, we have x squared subtract 11x plus 18 plus 49. This is actually equal to 67. This is equal to 0. Now we have a quadratic equation of the form ax squared plus bx plus c. This is equal to 0. Now from this quadratic equation, we have a equal to 1, b equal to negative 11, and c equal to 67. So the next step here, let's check the nature of the root of this quadratic equation by determining the discriminant value, which is b squared minus 4ac. Now let's substitute the values of a, b, and c here. So b here is negative 11, so we'll have negative 11 squared, subtract 4 times a, which is 1, then times c, which is 67. Now, here we have negative 11 squared. This is actually equal to 121. Subtract, this is 4 times. Now, 7 times 4 here, this is 28. And then we have 6 times 4, 24, plus 2, which is 26. So we have 268. And then 121 minus 268, this is actually equal to negative 147, which is less than 0. So that implies that we have two complex roots. We have two complex roots here. Okay? So we can solve these two complex roots actually by applying the quadratic formula, which is x2 and x3, which is negative b, plus or minus the square root of b squared minus 4ac, all this divided by 2 times a. So the next step, let's substitute the values of a, b, and c. We have b equal to negative 11, so we have negative 11 plus or minus b squared, this is negative 11 squared, subtract 4 times 1 times c, which is actually equal to, this is 67. All this divided by 2. Now here we have negative times negative 11, this is 11, plus or minus the square root of, this is 121, subtract 268, of which this is what we have here, divided by 2. So this implies that we'll have 11 plus or minus, now 121 subtract 268, this is actually negative 147. All this divided by 2. Okay? So here we'll have 11 plus or minus. We can express the square root of negative 147 as this is 49 times 3 times negative 1. All this divided by 2. So let's proceed from here. So now here we have 11 plus or minus the square root of 49 times 3 times negative 1 divided by 2. So we'll have 11 plus or minus the square root of 49, this is actually equal to 7. And then square root of negative 1, this is I. Okay. And then square root of 3. All this divided by 2. So here we'll have 11 plus or minus 7i square root of 3. All this divided by 2. So that means that we have x2 equal to 11 plus 7i square root of 3 divided by 2. And then we have x3 equal to 11 subtract 7i square root of 3. All this divided by 2. Now we have x2 and x3. Let's proceed to case 2. Let's proceed to case 2. Now from case 2, we have that x subtract 2 to power 3, okay, subtract 7 to power 3, this is equal to 0. Now this is actually the difference of 2 cubes expressed as a to power 3, subtract b to power 3, which we can express as a minus b, a squared plus ab plus b squared. Now let's apply this identity so that now we have x subtract 2, okay, subtract 7, and here we have x minus 2 squared, okay, plus we'll have 7x minus 2, then plus 7 squared, which is actually equal to 49. This is equal to 0. Now the next step here, we'll have x subtract 2 minus 2. This is actually subtract 9. Then here we have x minus 2 to the power 2. This is actually in the form of a minus b squared, okay, which is a squared plus b squared minus 2 times ab. So this is applying this algebraic identity. We'll have x subtract 9. Here we'll have x squared, okay, subtract 4x, then plus 4, okay, plus 7 multiplied by x minus 2 plus 49, okay, this is equal to 0. So let's proceed from here. So now we have that x minus 9 is equal to 0, and that means that x4 is equal to 9, okay? So the next part here, we have x to the power 2 subtract 4x plus 4. Let's open the bracket here. We'll have 7 times x. This is plus 7x. Then subtract 7 times 2, which is 14, negative 14. Then plus 49. This is equal to 0. The next step here, we have x to the power 2 subtract negative 4x plus 7x. This essentially is equal to plus 3x. Then plus 4 subtract 14. This is actually minus 10 plus 49. This is equal to 0. So you have x squared plus 3x plus times minus. So this becomes minus 10 plus 49. This is equal to 0. So here we'll have x to the power 2 plus 3x, negative 10 plus 49. This becomes plus 39. This is equal to 0. Now here we form a quadratic equation, okay, where a is equal to 1, b is equal to 3, and c is equal to 39. So to solve for the values of x5, that is x5 and x6, we apply the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac, all this divided by 2 times a. The next step here, let's substitute the values of a, b, and c. So we'll have negative 3 plus or minus the square root of b squared, which is 3 squared, subtract 4 times 1, okay, times c, which is equal to 39. All this divided by 2. Now here we have negative 3 plus or minus the square root of 3 squared minus 4 times 1 times 39 divided by 2. So here this is negative 3 plus or minus. Now 3 squared, this is 9. Subtract 4 times 39. So this is 9 times 4, which is 36. 6, carry 3. Then 4 times 3, 12 plus 3, this is 156 divided by 2. So here we'll have negative 3 plus or minus. Now 9 subtract 156, this is negative 147. All this divided by 2. The next step here, we'll have negative 3 plus or minus. We can express negative 147 as 49 times 3 times negative 1. All this divided by 2. So in this case, we'll have negative 3 plus or minus the square root of 49, which is 7, the square root of negative 1, which is I, and then square root of 3, all this divided by 2. So this implies that we have two complex roots here, that is x5. That implies that we have two complex roots here, that is x5, which is negative 3 plus 7i square root of 3 divided by 2. And we have x6, which is negative 3, subtract 7i square root of 3, all this divided by 2. So that implies that we have 6 solutions for this exponential problem. So kindly follow the steps, like this video and subscribe.